The interstellar comet 3I Atlas, discovered on July 1, 2025, is defying the laws of orbital mechanics. Instead of simply accelerating toward the Sun, it has begun a bizarre pattern of speeding up and slowing down with pulses every 17 minutes, as if ticking like a cosmic clock. Telescopes from Hawaii to Chile confirm the anomaly. Is it natural, jets of CO2 bursting from its frozen surface, or something far stranger, a relic older than Earth, a molecular vault from 7 billion years ago now sending shock waves through astronomy? What exactly is passing by us? On July 20, 2025, telescopes in Chile and Hawaii reported something unusual. The interstellar comet 3I Atlas was not behaving like a simple rock obeying gravity. Normally, an object entering the solar system follows a predictable curve: acceleration as it falls toward the Sun, deceleration as it moves away. But measurements showed irregularities. At 200 hours UTC, its speed increased by about 8 ms more than models predicted, then dropped slightly over the next 36 hours. This wasn't noise. Careful checks by the European Southern Observatory confirmed the anomaly on July 22nd, noting a measurable non-gravitational acceleration. The effect was tiny compared to gravity, roughly 10·7 astronomical units per day squared, but persistent. Astronomers compared it to the strange acceleration of Oumuamua in 2017, but stronger and more erratic. Instead of a smooth curve, 3 Atlas seemed to twitch forward and hold back. Even at one point, 2 astronomical units from the Sun when gravity dominates, the deviations could not be ignored. By late July 2025, the pattern deepened. Observers in Spain, Japan, and Arizona confirmed alternating phases of acceleration and slowing. Each phase lasted about 17 minutes, echoing brightness pulses already noticed in its coma. These weren't random jets. The intervals repeated with uncanny regularity. For comet physicists, it was maddening. Outgassing could cause thrust, but why would it act like a clock? If natural, the vents must open and close in cycles. If artificial, the implications were extraordinary. NASA's Jet Propulsion Laboratory issued a cautious note on July 28th, acknowledging non-gravitational perturbations. They compared them to thrust from CO2 and H2O sublimations seen in other comets. But privately, some researchers admitted the scale didn't match. Even with heavy carbon dioxide release, the forces required to alter a 30 to 40 kilometer nucleus by such amounts seemed excessive. The mystery grew. Was 3I Atlas a comet at all, or a relic with unknown physical processes at work? Its strange motion was more than a curiosity. For the first time, astronomers could watch an interstellar visitor accelerate and slow in ways our models could not fully explain. By the end of July 2025, the evidence was undeniable. This object was not simply coasting under gravity. Something else was pushing and pulling it. To uncover the cause, scientists turned to spectroscopy, scanning its coma for clues. And what they found only deepened the puzzle. In classical physics, an object's path is governed by gravity alone. If nothing else acts on it, its orbit can be plotted with Newton's equations or Einstein's refinements. For interstellar bodies like 3I Atlas, this means a hyperbolic trajectory. The eccentricity measured in August 2025 was greater than 1.04, confirming it was not bound to the Sun at perihelion around December 1, 2025. It should reach maximum speed before slowing forever. That was the expected script, yet reality broke the script. The Smithsonian Astrophysical Observatory tracked its speed rising to 130,000 mph on August 5th, then dipping slightly below models by August 7th. That's not supposed to happen. Gravity doesn't pause. Something was interfering. Outgassing is the usual suspect, but its distribution was asymmetric. At 2.0 astronomical units, comets often display steady sublimation, but 3I Atlas pulsed. The stop-start rhythm, repeating roughly every 1,000 seconds, hinted at processes deeper and stranger than solar heating. Comparisons were inevitable. Tuasai Borisov, discovered in 2019, behaved like a typical comet with smooth acceleration, driven by water and carbon monoxide sublimation. Funazi Oumuamua in 2017 defied explanation with non-gravitational acceleration lacking visible outgassing. 3I Atlas sat between these extremes, outgassing like a comet but deviating in rhythmic patterns like a machine. This hybrid behavior forced astronomers to rethink categories. Was there a third type of interstellar traveler, neither asteroid nor comet but something else? The most puzzling evidence came from modeling. Using Marsden's non-gravitational equations, orbital fits worked only if venting occurred at specific longitudes on the nucleus, turning on and off with solar rotation. That implied a rotating body with precise vent structures aligned to produce thrust cycles. But with an estimated rotation period of 17 minutes, 3I Atlas would be spinning faster than most known comets of its size. A body this large rotating that quickly should fly apart, yet it hadn't. By early August 2025, astronomers realized 3I Atlas was defying both orbital mechanics and comet models. It accelerated when it should have coasted, slowed when gravity demanded speed, and spun in rhythms that didn't make sense for a fragile ice ball. To decode the mystery, scientists shifted from orbital data to chemistry. What if the answers weren't in its motion alone, but in the molecules escaping from its surface? That's where the story of 3I Atlas became even stranger. Evidence from spectra and coma activity soon followed. The James Webb Space Telescope turned its infrared eye toward 3I Atlas on August 15, 2025. The data stunned analysts. Instead of a water-dominated spectrum like most comets, the object showed an unprecedented CO2 to H2O ratio. In fact, the amount of carbon dioxide was the highest ever measured in a comet, dwarfing even 2I Borisov's 2019 readings. Alongside it, Webb detected traces of formaldehyde, cyanide compounds, and even nickel signatures. This was a chemical cocktail unseen in our solar system. Back on Earth, the Very Large Telescope in Chile confirmed activity at 3.5 astronomical units, far earlier than most comets ignite. Normally, sublimation of water drives activity closer in, but here carbon dioxide venting dominated. The tail lengthened to nearly 600,000 kilometres, while brightness pulses matched the 17-minute cycle observed in its orbital anomalies. The chemical evidence aligned with the motion. Periodic outbursts of carbon dioxide jets strong enough to alter speed and trajectory, but in bizarrely regular intervals. The chemical fingerprints raised questions about origin. To form with such high CO2, 3I Atlas must have condensed in the carbon dioxide iceline of a protoplanetary disk. That region lies much colder and farther from a star than where water ice normally dominates. This suggested a parent star system with conditions very different from our Sun's. Computer models traced possible birthplaces to the galactic thick disk over 7 billion years ago, when the Milky Way was chemically young and volatile rich. Yet the preservation of such fragile molecules over billions of years was baffling. Cosmic rays and stellar heating should have destroyed carbonyl sulfide and formaldehyde long ago. Their survival implied shielding mechanisms, perhaps deep layering or unknown chemical stabilization. If true, 3I Atlas wasn't just a comet. It was a molecular vault, carrying a frozen record of galactic chemistry predating Earth by 3 billion years. And that vault wasn't quiet. It was erupting, accelerating, and slowing in defiance of expectations. By mid-August, the story had shifted from orbital oddities to chemical impossibilities. 3I Atlas carried more carbon dioxide than any comet known, pulsed with 17-minute eruptions, and preserved molecules older than our solar system. Its chemistry explained some of its motion, but not all. The deeper mystery remained. Why was it so regular, so clock-like, and so alien in composition? The answers would demand not just better telescopes, but a complete rethinking of how interstellar objects are born and evolve. When NASA released refined orbital simulations on August 22, 2025, they carried an astonishing conclusion. 3I Atlas may be older than the Earth itself. Its trajectory traced backward suggested a likely origin in the galactic thick disk, a stellar population more than 7 billion years old. That means this comet predates our 4.5 billion-year solar system by nearly 3 billion years. To astronomers, this was like finding a fossil from a vanished era of the galaxy, drifting intact into our neighborhood.